If you tolerance your parts badly and it can't solve. Yeah, so I'm going to go into this position tolerance, and I'm going to change it. Notice now how we've combined this. This is a little sidebar. I wrote two separate callouts. I put a size tolerance on these holes, and then I put a position tolerance on those holes. But now if I go into either one of these, it's showing me that, hey, these two features have got a size tolerance on it of 0.2 and a position tolerance on it of 2. And you can edit, either one of these. I forget how to make that arrow go up there. On the very top. Oh, up here. Okay. Thank you. So you can see it's showing us everything that's applied to these features. And depending on what I want to edit, I can hit this pull down and change where this arrow is pointing to. I want to just change this to 3 millimeters. Okay. Get a visual so you can see those are moving around a little bit more now. And then when I build this and run an analysis, now you can see it's still built, but now it could only build 1,982. So based on how we toleranced our parts and how we're trying to constrain it, meaning locating the lifter with the hole pattern, it can't solve it. So now you would have to address this by either increasing the clearance holes on increasing the holes on your lifter, decreasing the position tolerance on your lifter, decreasing the pin size on your base, whatever you need to do. If we look at, let me minimize some of my tree here. If we look at the rocker, you can see I have all kinds of GD&T on here now. I got a linear size tolerance, I got a coordinate size, origin size tolerance, datum A, datum B, datum C, perpendicular, profile, flatness, and location on those surfaces. I'm going to, just so that I can make a mistake, I'm going to also add parallelism. Add to this top surface. Oh, that top surface was datum B, wasn't it? Sorry, I don't want to do that. Let's add this bottom surface. So I got parallelism. I'm going to say 3 millimeters so I can see something, and I'm just going to say okay. Okay. So you can see that surface is deviating for parallelism. However, I did not define it back to any datums, and if you don't do that, then just like our original software, we are deviating it from nominal, and it's not related back to a datum reference frame. So when you're all done with tolerancing your parts, actually when you're all done writing moves, tolerancing, and measurements, obviously the first thing you want to do is hit validate. And you can see that I have rigid body move uses a non-point. That's an error I didn't know I made. I'll have to check on that one. Wasn't supposed to be any errors in this model. But the other thing that you can do is you can come up here and you can run your tolerance wizard. This is, a lot of people don't know about this. It's a very nice function. I'm starting to use it more and more, and I'm liking it more and more. But if I run my tolerance wizard, it's going to give you this box here. And if we go to, let's go to the rocker and expand my tolerances. And you can see it's telling me that it's, okay with the tolerances, but this tolerance here is red. And it's, if you look at the color coding down here, GD&T is invalid. It's got 3 millimeters, GTOL 17. It's parallelism, invalid syntax, material condition, invalid material. Oh, I might have screwed that up too. And it requires a DRF. That's really interesting. I could go in and fix that material condition. It probably has one and it's not supposed to. And also, it's got a, okay. So I purposely made it wrong so that you could see what the syntax, what the tolerance wizard would tell you. So I don't care if it's wrong. That was my goal. And also, if you see, up here under the feature list, you can see these feature lists are all listed as yellow. And that's because it's got tolerances in them, but it's not used in a move or a measure. So the idea is when you think you're done with your model, and I tell everybody when I'm training them that if it's not a datum and it's used in a move or a measure, it needs to be toleranced. So this helps you take a glance at all the features in your model. And if I have a feature that's in my model that's not being used, it's going to show you up here. If I have some GD&T that's wrong, it's going to show you down here. And then, we have validations for moves and measures as well. I just wanted to show you quickly that this function exists and that you can use it to help validate your GD&T.